This video is made in Boorloo, Perth, on Wajak Noongar Budja.
Kaya, welcome to Michelle from Perth, the internet video show with the Perth Science Facts. This week, sunsets on the beach. As anyone scrolling through Instagram at 6 PM will know, Perth has some pretty good sunsets. Being able to sit on a towel at the beach with a beer in your hand and take it all in.
How's the serenity?
But I wanted to know how sunsets work. Turns out the reason sunsets are red and orange is the same reason the sky is blue, which has to do with the way sunlight interacts with molecules in the Earth's atmosphere. And here is where I tell you that physics makes me stressed. But we have to do this together. First, I'm going to introduce some key players. When I say molecules in the atmosphere, I'm talking about the pairs of nitrogen and oxygen atoms that make up air. Light is also made up of particles, or is it a wave? Both. I know, bear with me. Light from the sun is white, which is made by mixing the whole spectrum of visible colours from violet to red. Each colour corresponds to light with a different wavelength, literally the distance between one peak and the next of this electromagnetic up and down. What we see when we look at an object is light from the sun or a lamp that's bouncing off the object into our eye holes. But when that object is small, say many times smaller than the wavelengths of visible light, like an air molecule, something called Rayleigh scattering occurs, which is light being redirected by a small particle according to its wavelength. To talk about Rayleigh scattering, let's take a trip to the 10th birthday party destination of my dreams, Bayswater Waves. Visualise the wave pool. Put one small child in a rubber pool ring in the wave pool. They are an oxygen molecule. The waves are light. Because the child is much smaller than the waves, when a wave hits they go up, then back down. What I'm trying to say is when light hits a small particle, the particle oscillates. When they are hit by the wave, imagine small ripples spreading outward from the kid. This is scattering. To take it back to physics, light hits a particle and gets scattered, or thrown off in another direction. Because violet and blue light have the smallest wavelengths, the shortest distance between one wave and the next, they make our molecule/wave pool kid bob up and down a lot faster, scattering more light than the further apart orange and red waves. The takeaway from this is that violet and blue light are scattered the most, meaning that when we look at a point in the sky, that's what's being bounced back into our eyes. But Michelle, you ask, if violet has the shortest wavelength, why isn't the sky violet? Good question. It would be, except humans are much better at seeing blue. So how do we get from blue skies to sunsets? The difference is the position of the sun, and how much atmosphere the light has to travel through to reach us. When the sun's on the horizon, the light has to travel much further than when it's overhead, meaning more chances for it to hit particles along the way. Early on in the journey, blue wavelengths are scattered away to colour someone else's afternoon, leaving only the yellow, red and orange wavelengths by the time the light makes its way to you. Before we talk about what makes any particular sunset a stunner, an aside. You know, this episode was originally going to be called Why Do Backpackers Get Sunburned? But it turned out to be too easy. The answer is because that Perth sun really does hit different. During our summer, the Earth's orbit brings Australia and the whole southern hemisphere closer to the sun than Europe during its summer, resulting in 7% more solar UV intensity. Plus the ozone layer is thinner over Australia and our weather is better. All up, Australia gets 15% more UV than Europe, which is what turns unsuspecting British backpackers into boiled lobsters. Backpackers get more sunburned because we have more sun. So now you know, back to the show. There's one main factor that can make or break a sunset: clouds. The right kind of clouds can make everything sing. The wrong kind of clouds can make everything a bit shit. What we want to see are medium or high clouds, about 5 to 13 Ks up in the atmosphere. This way, light from the setting sun on the horizon can hit the bottom of the clouds, which then reflect those bright rays right into your little eyes. What we hate are low clouds, haze or smoke, which are going to block out the sun and stop that light from reaching you. Why stop at asking why the sky is blue if you can also ask why clouds are white? Remember Rayleigh scattering? Small particles are great at scattering light according to wavelength. Well, clouds are made up of water droplets, which are a lot bigger. So all wavelengths of light, meaning all colours, are scattered and reflected equally, making clouds appear white. The final things that give Perth sunsets the edge, apart from the option of watching one at the beach, are our clear air and low humidity. Fewer big molecules like pollutants and water in the air means the colours come through clean and bright, all the better for us, our beach beers and our Instagrams. So next time you see a sunset, who am I kidding? This conclusion is a little reminder for me personally. Next time you think you know the sky is blue, you think it'll be real easy to make a video explaining sunsets in Perth, just remember, physics is really hard. But seriously, keep asking dumb questions, because it might turn out the answers are bigger and more interconnected than you'd think. Thanks for watching. If you liked this, why not chuck us a follow on YouTube or Instagram at Michelle from Perth. There's a new video every fortnight, and in the meantime, stay cool.